in match problem 7, we want to start getting an understanding of what we can do with the derivative once we find it. So let's start off by finding the derivative of this given function. So f prime of x is going to be 4x cubed minus 24x squared plus the derivative of 7 is just going to be 0. So once we figured out this derivative function, we can plug in any value for x and find the slope or the rate of change of our function at that point. So at a particular value for x, how quickly is our function increasing or decreasing? Part B, we want to find the equation of the tangent line at x equals 1. So in order to do that, the first thing we need to do is find the slope of our tangent line. So the slope of our tangent line is going to be our derivative function evaluated at x equals 1, which is going to be 4 minus 24, or negative 20. So once we have the slope, we can start establishing that general slope-intercept form. So y equals mx plus b. And now instead of m, we've already found that our slope is negative 20. So the last thing we need to solve for to have the complete equation for this line is we need to find our y-intercept. So what we need to do is plug in a value for x and y that solves this equation. So since we're considering this line at the point x equals 1, we want to go back to the original function and plug in x equals 1. In this case, that's going to give us 1 minus 8 plus 7, or 0. So we know that our value for x is 1, or when our value of x is 1, our value for y is 0. So we can plug in 0 equals negative 20 x plus, times 1 plus some unknown value b. So solving for b, negative 20 times 1 is going to be negative 20. To get b by itself, we would add 20 to both sides. So that tells us that our value for b is exactly equal to 20, meaning the equation for our tangent line at this point is y equals negative 20x plus 20. So once we have the derivative, we can find the rate of change or the slope of our function at any given x value, in this case x equals 1. Once we have the slope, we can come up with an equation for that tangent line. We can also look at, in part C, answering or finding values of x where our tangent line is horizontal. So if our tangent line is horizontal, that means our tangent line has a slope of 0. So to figure out where our tangent line has a slope of 0 means we want to find where does our function have a rate of change equal to 0. So we're going to take the derivative function and set that equal to 0. So when our rate of change is 0, the slope of our tangent line is 0, so the tangent line is going to be horizontal. So taking the derivative function, which is 4x cubed minus 24x squared, and setting that equal to 0, now we need to factor and solve. So here we can factor out 4x squared, which leaves us with x minus 6 equals 0. So that will be true whenever x equals 0 or x equals 6. So at x equals 0 and x equals 6, our function has a horizontal tangent line, or no rate of change. So for right now, we don't have any application tied to this, but very soon what we're going to be looking at is taking, for instance, a profit function, P of x, and trying to find when is our profit optimized. So in this case, that's always going to be at the peak of this parabola when our tangent line is completely horizontal. So as we trace up this line, our profits are increasing more and more and more and more as our production level increases. So we want to find the optimal production level. Our profits continue to increase until we reach the top of this parabola, giving us that optimal point. And then once we start increasing production beyond that, our profits start to decrease, meaning we're losing money. So an application of finding where is the slope of the tangent line equal to 0, where is the tangent line horizontal, is going to come into maximizing revenue, maximizing profits, trying to find the point where the rate of change of that profit function or revenue function is equal to 0. That's always going to give us the peak value, that maximum profit or revenue.